So we'll give you a quick overview of our usage of Aeron in our low latency FX trading system. I'm Oscar Wantola, and I head up execution technology at Man Group. Execution technology team looks after all the trading technology within Man Group, so anything from management of orders, market connectivity, algorithmic trading, and trader tools, and so on. Prior to joining Man Group 4 years ago, I've been working in a few investment banks doing roughly the same thing. And I have to tell you that all execution technology stacks, they from high level look all the same. Distributed microservices with messaging system between. So I've seen quite a few different messaging systems.
Hi, my name is Tim Raggatt. I'm a staff engineer at Man Group, and I've been here for about 7.5 years working in execution technology. I've worked fairly extensively on our FX execution infrastructure. Probably most of that time it's been on Aeron. And yeah, I was one of the lead engineers when we integrated Aeron at Man and managed to get the first production deployment. Prior to Man, I've worked in financial technology and at investment banks and a startup.
So let me give you a quick introduction to FX trading at Man Group. So the system that we're going to be talking about trades only $1.5 trillion. I say only because Stefan's system obviously handles much more than that. I guess Man Group is not as rich as the population of Switzerland. The system is fully automated, so there is no human interaction. Now, why latency matters in FX? So liquidity providers stream FX quotes to market participants, and based on those quotes, market participants would send orders to based on best available quote, and that order might be traded based on those quotes, or that order might expire if the quote expired. And one of the reasons why the quote might expire is because someone else took that quote. So the best quotes are taken by the fastest participants. Now, we've been using different messaging solution before we looked for something faster, and we are looking for a fast alternative. So why Aeron? So first of all, we were looking for something low latency, including not having long tails. If you trade 100,000 of orders a day, you don't want thousands of them to be rejected or expired. We found Aeron, which is open source, low latency, reliable, used in financial industry. And some of us also read Mechanical Sympathy by Martin Thompson, and we really like the content. It's worth mentioning that we did this migration quite a few years back. So at that point, I think we found in one of the comments that Aeron is the messaging system that some of the patterns and concepts from Mechanical Sympathy were being used.
So this is the FX trading system where we integrated Aeron. So I'm just going to tell you a little bit about how it works. So this is a price-taking system in that we connect to a number of different venues and request streams from them of FX quotes. So FX markets operate pretty much 24/5. So they open Monday morning in Asia and run pretty much continually throughout the week until close of business in New York. And so throughout that period, FX quotes are typically just continually available. So what we do is we connect directly to a number of different venues. So that would be banks and other liquidity providers. And we talk directly to them because this is an OTC market. And they stream us quotes, which are all tradable. So we can decide to send an order against the buy side or the sell side of every single quote message that we receive. This is all done over FIX. So those quotes stream into our liquidity provider adapters. So we have an adapter per venue, and its role is to cache the latest liquidity that's available at that venue. So when asked, they can tell you what is the best buy, what is the best sell. So that's the external facing part. Internally, we have our investment engines upstream of all of this stuff, which are generating orders. So it might be just an order like buy 1 million euros worth of euro dollar. That would flow into our system, and then it's our responsibility to find the best price for that order. So the first thing we'll do is we'll establish an algo container that will have all the order state in it. And that will submit out a RFQ down to these adapters to request all the best possible quotes. They'll then respond with a stream of quotes, which update in real time, back into the algo container. They get aggregated, they get ranked according to how competitive they are, and they stream into the algo. And the algo will just sit there watching the markets move, and at some point later it will decide now is a good time to trade. And then finally, when the algo container sends that order down, it will go to one of these adapters, whichever was offering the best price at that time, and hopefully we get a execution back. So you probably guessed that the area here where we were looking at Aeron was this part in between the liquidity provider adapters and the algo. So we were using, when we started looking at Aeron, we were using a proprietary middleware, which we wanted to move away from for the reasons that Oscar said. And so we needed to think about how Aeron would fit into this infrastructure. And so the first thing we did was to build a simulator which could simulate the sorts of traffic that we needed to be able to host over this middleware. So we built this simulator, which was, I suppose, sort of something like a proof of concept that we could fit Aeron into this place. So what we had is the algo on the left-hand side and the sort of a fake adapter on the right-hand side, and we put with the media driver in the middle, and they talk to each other over streams. And we'd sort of run these simulations where it simulated particular quote patterns, like different quote rates. So one of the challenges in FX is that you're not always getting super fast rates of quotes. Some markets move faster than others. Eurodollar is a good example of quite a fast-moving market because it's so heavily traded. But there are other currency pairs which may be perhaps a little bit more obscure and not traded so often. But in both cases, you still care about latency, even if you've got really fast ticking data, or if you've got slow data. You still care about getting those quotes into your algo container as soon as possible. So interestingly, what we found was with the faster ticking scenarios, everything just worked really well, and latency was good. With the slower ticking scenarios, we ran into some issues, which was a bit of a surprise to us because Aeron had this amazing reputation. And so we had to sort of spend some time investigating. What we've traced it back to was the idle strategy. What was happening was, so people who are familiar with Aeron probably know about the idle strategy, which is essentially your bit of logic which determines what the thread does when there's no work to do. And that was an issue for these slower ticking scenarios. In the case when, initially the idle strategy, the idle strategy we wanted to use was the back-off idle strategy. And the way that works is that first you start spinning, and then you start yielding to try and get off the CPU, and then eventually you park if there's still nothing to do. What we found was when we were getting into the park part, the thread just wasn't waking up reliably. It would sometimes take like up to a millisecond for it to wake up. And so this gave us a very unpredictable latency profile. For the faster scenarios, it would be, or faster ticking scenarios, it would be fine. It would sort of say hot. Or slower ticking, it would be quite unpredictable. We experimented with a range of different sort of approaches here, and we tried sort of implementing our own idle strategies. But one of the benefits of the simulator approach was that we implemented this for Aeron. We also implemented the same thing could run on the older middleware as well, the legacy solution. We actually found that they were actually roughly similar when deployed on this particular host. So it kind of gave us confidence that we could probably make do initially. The other thing was that we actually had planned anyway that we were going to be moving to a slightly a different host which had a different Linux kernel. And so when we ran Aeron there with the simulator, we found that it actually performed really well for fast and slow ticking scenarios. So we knew we had that kind of in the near future. So we then kind of had this dilemma about how we got from our first host to our second host. So did we deploy Aeron first in a sort of suboptimal mode on the host one, or did we move the legacy middleware over to the second host and then move to Aeron? Well, as I mentioned before, the simulator actually showed that the performance was okay on the first host. So that's the approach that we took. So yeah, first we have Aeron on the first host, and then secondly we moved the system over. And in terms of latency, and we can't show specific numbers about our latency because this is slightly sensitive, but these are the percentiles that we were experiencing and it's on a logarithmic scale, so these are sort of order of magnitude improvements. But you can sort of see the two phases. So in the first instance, when we moved to Aeron initially, the 10th percentile, like the sort of happy case, improved, so clearly faster. And the other percentiles weren't really affected so much. But then when we got to the new host, then everything just shifted down, we saw order of magnitude improvement across all the percentiles.
So based on that experience, firstly moving to Aeron, but also upgrading the kernel, we now use Aeron Transport and Aeron Archive for our FX trading. So new IPC, multicast RFQ, significant performance gains compared to the previous version of the system. We now have the real-time message fix, reply, monitoring, and simulation thanks to Archive. And after that, we decided, yes, Aeron is the technology that we want to use at Man Group in execution. It's been added to our toolkit, and we have been leveraging it in other areas, in equities, in futures, algorithmic trading platforms. What are we looking now is integrating with ArcticDB for real-time diagnostic, real-time analytics. As Stefan mentioned, with Aeron, you start realizing that you have less insight to your data. So we trying to use ArcticDB to gain that insight. Cool, thank you.
Understanding a lot of that detail is just what our audience has been asking for, so really appreciate that. So thanks, Tim. Thanks, Oscar. Yeah, any questions?
Why didn't you go with the busy spinning strategy in the first place?
Yeah, that's a good question. So I suppose part of the reason we didn't go for that one was part of the constraints of doing a retrofit, I suppose, that this was an application that was built sometime before we did the integration. And I think it was built in a style that you probably wouldn't do it if you were building it from scratch with Aeron. So this application is heavily multi-threaded, and so I think it just wouldn't be a very scalable strategy if you were using the busy spin strategy across all those threads. So yeah, ultimately we wanted to constrain it a little bit, I suppose.